Excel sheet, you can see that on the first column is going to be our mass of the sugar, right? Starting from 2 grams to 14 grams, and make sure to write down all the significant figures. That would be the column B from our table. And then the second column, you have to draw density, right? Density, again 4 significant figures. So you're going to go ahead and highlight the 2 columns, and then you're going to go to insert, and then you go to charts, and then you pick the first one, which is the scatter one. Okay, and then so any chart, we need to have a chart title. So chart title, you can go ahead and write down the same thing that I have written over here: density of sugar solution versus mass of sugar. Okay, and for any chart, we also need to label the axis. So you go over here and then you click plus sign, and then axis titles, that will show up these slots. So this one is going to be your mass of sugar. You have to put the units as well, okay, grams. And then on this side is going to be density of sugar solution, grams per milliliters. So this is a perfect graph, don't you think so? Just like you guys, right? It's not a zigzag. So we can see that, and we need to connect these dots covering all the area. When we are drawing it, you are not just go from one dot to another one. So we need to draw the best fit line. So you click trend line. So when you click the trend line, you see here this is little off, and this is little off too, but it's mostly covering the whole area. Okay, excuse me. And then after you get your best fit line, the most important thing for us is the equation from the graph. So you're gonna go to the graph and you right click, and then you say format trend line, and then on the right side you go and find display equation on chart. So this equation is important for us to do the rest of our calculations. Okay, so and when you are turning in your lab report, make sure to turn in this graph as well, and draw this on Excel, not on Google Sheet. Okay, and you have Excel for free for students at ACC, and also we have it in library. So
You said you right click and then you what?
You right click and then you get this okay, what did happen here? So let me do it again. So you right click here and then do format trend line, and then on this side you see here there are 3 things: set, intercept, display equation on chart is what we want, and then the last one is display r squared value on chart. We don't need that. Okay, so you click this one, then it will show you this equation. Okay, and then we need that equation to do our rest of the calculations. So I'm going to go ahead and write it over here. Y equals 0.0038 x plus 0.9941. Okay, so let's go back to our handout report sheet, and your first question is: use the data and results for the sugar solutions to construct a graph of density versus mass of sugar. We just now did that, right? And then fit the data to a linear relationship. We did that too. Use the graph paper provided. So you're not going to do it on the graph paper. Just disregard that. We're all going to do it on computer, on Excel. Okay? And then use your calibration curve to determine the mass of sugar in 100 milliliters of each soda sample that you have studied, and then report your results to the right column. And let's see how to do that part from the data. I also have written here the instructions, but there should be another handout on Blackboard without these instructions. So that's what you need to turn in when you are turning in. Okay, so you can write, show me how you did your calculations. Okay, so we have this. Now let's see. Remember, we are able to calculate the density ahead of time for the soda samples 1 and 2, right? And let's assume one of the soda sample, when we did our density calculation, it came to be 1.028 grams per milliliters. I picked this number so that it will fit in our calibration curve. You see here 1.025, 1.038. So the number I picked is 1.028. Let's say that's going to be the density of one of the soda samples. Okay, that you calculated. So how do we find out the amount of sugar in that soda sample using our equation? What do we need to do? What do we have on y-axis? In our calibration curve, what do we have on the y-axis?
Density.
It's the density. So the y-axis we have density. And what do we have on the x-axis?
Mass.
The mass of the sugar. So this is going to be the mass of the sugar. Correct? So if you know the density of the unknown soda sample as 1.028, how do we use that to get the mass of the sugar using our calibration curve? What do we need to do? Plug into y, right? Yes. So you're going to use this number 1.028 equals 0.0038 x plus 0.9941. Excuse me. So can we go ahead and find x? All of you, can you do that and tell me what's the number you're going to get? So your x is going to be 1.028 minus 0.9941. So you first do the subtraction and you divide by 0038. It would come something like 8.9 something. Did anyone do the calculation? 8.921 grams, right? So this is the amount of the sugar in the first soda sample. So that you're gonna go ahead and write down under F, grams of sugar in 100 milliliters, right? So you're gonna write it down and you do the same thing for your second soda sample too. And then the next, calculate the mass of the sugar in 12 fluid ounces can of each soda sample. And then you can write it down over here in 12 ounces can, right? How do we do that? So you take this amount, 8.92, so I have written here how to do the calculation. 8.92 grams, and this was in how many milliliters? 100 milliliters. So 100 milliliters, and then if you drank 12 ounces sample, and then we need to do our conversion. 12 ounces equals, it's given 355 milliliters. So this can basically get cancelled. And what's going to be the mass going to be? 30. Can you do the calculation, Brooke? Working on it?
31.7.
31.7 grams. Okay, and that you're going to write down under G, calculated grams of sugar in 12 ounces sample. And then we have to do one more thing, and that's going to be calculating the percent error. So how do we calculate the percent error? So you are given the actual grams, 39 and 43. Excuse me. So how do you calculate the percent error? That's going to be actual minus the measured and divide by actual amount times 100. Correct? So where do we find the actual grams of sugar? In which column? So you are given it over here, right? 39 grams for the first soda sample. So percent error going to be your 39 grams. Subtract G, that's going to be 31.7, and then you divide by 39 actual grams times 100, right? So you have to take the absolute value and then you write down the percent error, and you do the same thing with your second soda sample too. Okay, Any question?